Today's episode is made possible through the support of the Thought Emporium, which is a really awesome YouTube channel that you should check out, and a whole bunch of people on Patreon just like you. Thank you guys for everything you do to help me be able to teach people about science, technology, and engineering. Thank you. Hi there guys, I'm Chris Boden, and welcome back to the shop for episode 7 on the Project ARchi videos. And today is pretty cool because I've been waiting for this part to get here for weeks. This has been the holdup on why you have not seen a new episode in the past couple weeks. This is the SV-166-1C25 Microswitch. Now this particular model of Microswitch is special because it has a little roller wheel. Now the only reason my robot has a Microswitch with a roller wheel is because that's what the book says. And I am working diligently to make this robot exactly by the book. I have, over here, I have a whole bag full of other microswitches, some of which you actually need for this robot, that look like this. This is the XV-152-1C25, and you can see they're very, very similar. They're pretty much exactly the same, except this one has a little roller wheel on the end, this one doesn't. I personally believe that this microswitch would work just fine for this application. But I also believe in the Easter Bunny, so you might want to, check that. But to me, this would work just fine because it's only getting an impact like laterally. It's just coming along and boop, and that's it. That's all this is ever going to see. Just boop. It's the limit switch for J1 when it comes around, and that little bolt touches right there, just like that, and that's it. It's not, you don't need a roller switch here. So if it's what you got, if this is all you got, I say go with this and you'll probably be fine. But the book says this, and Chris Annan knows a hell of a lot more about robots than I'm ever going to know. So if he says put a roller switch, do it. But I think the only reason a roller switch is on there is because that's what he happened to have in his parts box that day. That's just me. Okay, so to get started, we're going to be rocking out, you're going to have this, which is your 22 gauge wire that is the red and the black. So we're going to need a little bit of that. And we're going to need some of the white wire, which is also 22 gauge. Highly efficient, super flexible silicone wire. I don't know about highly efficient. I'd say it's decent. If you want to make it highly efficient, well, we're going to have to get into some cryogenics. But I'm game if you are. I can party like that. So this is a really dopey way for wire to come, but they send it in a little pouch so that it can get well and truly tangled. You're going to need 10 inches of each. So measure out and cut 10 inches of red, white, and black. I'm just going to lay it right down on my bench and do it here because I've got the nifty measurement bench. So the book says 10, I'm cutting at 11 because it's really easy to trim an inch off, but it don't stretch worth a shit. So we've got our wire. We'll set the extra aside. Jesus. Okay. We've got the right switch. We'll set the wrong switch aside. So we've got our 3 wires here, and we can just move the robot right out of the way. So we got our 3 wires. And now is where things get interesting, because we have to put these on the wire. This is a 90-degree crimp connect female spade terminal. And these suck. These are a horrible thing to work with. And let me show you why. Let me wander over here a minute because I have an excellent teaching aid for this. You ready for some live nude action? Check this out. This is what a 90-degree crimp connect looks like normally. This is what they look like naked. Oh yeah. All right, so these are a few different sizes, but this is what's in there. And the reason these suck is on this style, you can see there's that little tube off the end. If you have the opportunity, you need them insulated. They got to have the vinyl or nylon or whatever they got on the outside. But some of them come with the little tailpipe here. Wait a minute. Maybe these are just males. All right, I'm going with these are males. So some of them come with the appendage, and some of them don't. You can see in there, this is just plastic, this whole piece here. And you got to watch out for this when you buy crimp connects, because the only thing this has to actually crimp down on a wire is that it's missing the thing. So that's a problem when it comes time to crimp it, because you want to grab this with your crimpers, and somebody who doesn't catch that would just put it in your crimpers like this and crimp down on that part, and you're just crushing plastic there. You're not actually, these work by crushing the metal. So when that's all you have is just this portion of the metal, that's all you can crimp. This is not the best way to do this, but they're the connectors I have, so this is what I'm going to use. Aside from that, it's pretty simple. Now we see we have an engagement on here of about 1 centimeter. So we'll go here, strip off about 1 centimeter. So the question is, how can you crimp this onto here? I'll show you. I'll show you how I'm doing it. Doesn't mean it's the right way, it just means it's the way I figured out on how to do it. So you put that, now you see that there, that's how you want that to end up. You want to have the wire pretty much bottom out into the connector, and you don't want to crimp any insulation. So get that as far in there as you can without crimping insulation. And then grab a really big, relatively expensive pair of crimpers. This is how I'm doing it with this style of crimper, because it bites down on the end. And I'm going to put that in the end and just squeeze the hell out of it. And either it'll bite or it won't. Okay, we didn't break the outer plastic. Is secure. I'm calling it good. That is not the best way to do that. I'm not entirely sure how. That's just what I got. See, the cool thing about these videos is I learn just as much as I share, because somebody's going to comment and be like, "You idiot! The fuck are you doing? Here's the crimpers you should have for that." And sometimes really cool people will actually send me a set of those in. And I could certainly use a set for this, because I have no idea how the hell I'm supposed to crimp these. But I'm going to do it with what I got. Because while this isn't the proper way to do it, one of the best lessons I can teach you guys, do what you can with what you have where you are. Just figure it out. That's half the world of engineering. And those are the limitations that you're going to learn to work under, is do what you can with what you got where you are. Don't just put it off, fix it. It's what engineers do. It's how we think. We fix things. And you will learn over time to improve what you have, which is why I carry a Gerber or a Leatherman and a Swiss Army knife everywhere I go. I carry a flashlight with me everywhere I go, because you'll learn really quick, those are useful, really useful. And as I got older, I learned to keep a tool bag in the car, keep a med kit in the car too, everywhere I go, because you will have experiences in your life where not only could you potentially save the day, you could save a life, and the life that you end up saving might be you. Especially if you do stupid stuff like play with robots and lasers and high voltage and all the other stuff that I play with. Be prepared, man, it works. All right, so that one's on there. Now just things to note, it's good to not crush the metal or the plastic too much, because well, it's good to not break the plastic. You can crush the hell out of it, but just don't poke any holes in it. And it's easy to do that with what we're doing here, with all that force on it. So I'm going to grab my meter a moment, because I want to test these and just make sure that we didn't crimp down on the insulation or anything like that, because I got 15 things going on. I'm trying to pay attention to all kinds of stuff, and I want to make sure I didn't screw it up, because it's really easy to have a screw up there and not be able to see it for a long time. Okay, so I got my meter here, and we're just doing a continuity check, because as long as I got continuity from A to B, we're fine. Hey, this worked. No, I can do that. I can do that. I got skills. So we'll just stick that in there, and we'll touch these two ends together. Okay, so that one's good. And this is just a simple, think of this like quality control check here. Okay, black is good. And white's good. All right. And always remember to turn your meter off, or your battery will be dead next time you want to use it. One of those must-have tools that you should own, a good basic multimeter. Dave over at EEV Blog sells them really cheap. He's got a good one, and if you want to spend the money, get a Fluke. Nothing compares. Absolutely the best. All right, so we've got our wires sorted out. Now, if we look on the switch, we're going to learn a little bit about microswitches. So first off, you're going to see this style of switch, like the little rectangle box with 2 or 3 pins, almost always 3, and a little button under here. See the little thing? That's the actual button under there. Is the little black thing tucked in there? Right there. That's the actual switch button. The lever is eminently modifiable, and as you work through various projects, you will cut, shape, bend, twiddle, freak out this little piece of metal in 1,000 different ways to get this switch to do what you want. These 2 holes here are for mounting the switch, and you can fit an M3, works great in there. And these 3 things are the contacts. Now, why are there 3 contacts on the switch? All a switch is, like if you look at a schematic of a switch, it's just boop, boop. It's either closed or open, on or off, right? Well, it's not. This switch, internally, if you just have one switch like this, and like this switch, and it's normally open, so when you activate the switch, it closes the contacts. This is called, this here is your common, the big finger, and the little finger down here is your normally open, okay? So it's open right now, and when you click it, it goes boop, okay? So that's closed, that's open. This is a normally open switch. So when it changes state, when it goes from here to here, it's closed. So inside this switch, it has 2 fingers on this side, and it works like this. Right now the switch is sitting like this, and when you click it, it goes boop. So this is normally, these 2 connections here are normally closed, and when you actuate the switch, this one opens, and it moves down here, and this one closes. So this is your normally open, and this is your normally closed. So it goes click, and then when you let go, click, it goes back to here. So this one normally at rest. So this is the switch at rest. This is the switch normally. And then this is activated. So right now, one of these is the long finger. That's the common, because it'll go anywhere. And then over here, one of these is normally closed and is sitting like that. And then one of these is normally open and is sitting open. And when you change state, click, it goes from here to here. So you'll have normally closed, that's this finger, normally open, and then common. Okay. If you look closely on the switch, you'll be able to see common down here. It says COM. Up here is normally open, and then this is normally closed. You'll see an NC here and an NO here, and you'll see these on switches, you'll see them on relays, you'll see them all over the place. This is a standard nomenclature for switches and relays and stuff like that. Common is the long finger that moves around. Normally closed is where it's resting at its ground rest state. And then normally open is where it's going to go to when it changes states. This works with relays, this works with switches, works with all kinds of stuff. Normally open, normally closed, and common. Now you know everything you need to know about that. So on this particular switch, we got to orient it the way we want it to go on the robot. So let me make sure we got pointing the right way. Yep. Okay, so that's how the picture looks. All right, so we want our white to our common. That's going to go off like this. And these connect. This is your male spade fitting, this is your female. So white to common just slides right on there, and it's going to be, it's a squeeze, but you get it all the way up like that. Okay, see how much is sticking out? If yours looks like that, because you'll see there's a step. See the step? If yours looks like this, and you're all the way down to the thing, it'll probably work fine. But it means you got one size too small on the things. These will go all the way up, like that, and now you're insulating and protecting the whole thing a lot more. Yes, there's an open contact here, but it's not gonna be a problem unless you're using this next to like somebody grinding steel or something. This is how you want it to look. White goes to common, and this is gonna mount on the robot that way, and the thing's gonna come around here. So you want the wires coming off this side. Okay, that's how it should look. Now black goes to your normally closed. So this is your black wire. Your normally closed terminal is over here. It may be in a different spot. Different manufacturers do different things with switches. So make sure the black goes on your normally closed, NC. And then red goes on normally open. And we just work that on. Like that, and this is how it should look. Assuming you use the exact same part number, the SV1661C25, this is how your switch should look right now. So now is where things get weird, because, well, really, Chris Annan hates us. And he could have very easily made this part like an inch longer, but he didn't because he hates us and he wants us to suffer. So here's what we got to do. See this beautiful switch? Just perfect. This is how it's supposed to look. This is how it's supposed to work. Now we have to butcher it, because what we're going to do is we're going to grab a big ass screwdriver. We're going to go right here. We're going to grab this thing here, and we're going to jam it in here, and we're going to spread these apart by quite a bit. You may break your switch doing this. It could happen. It's not a big deal if you do, because the switches are super cheap, and when I bought them, they come in like 5 or 10 packs. Oh yeah, that's fucked up a little bit, but I'll bet it still works fine. So you got to spread them way the hell out like that. And the reason you do is because this fucking part is not how it should be. See that? This could have been taller. The turret right here could have been taller. Let me try and show you that a little bit better, because it's really hard on the overhead camera. This turret right here could be a half an inch taller. It'd be fine. It'd look better. It'd taste better. It'd be more aesthetically appealing. But because it's not, this switch sits too low, and we got to splay out the connections so that the switch will fit. He could make it, I don't know, 1.5 inches taller, and we wouldn't have to use these fucky right angle connectors. We could just go straight off it and bend the wire, and it'd be fine. It'd be totally cool. We could do that. But because this is what we have, and because you have to do the best you can with what you have, where you are, we have to spread the legs out to get that thing on there. Because if you spread the legs out, then the holes will line up on the back, and you're gonna have your holes on the back. Is there a better way to? There's always a better way. I could just take the motor off, and I'd really let you see it. But okay, So you see our holes, and the switch is going to mount on the back like that. And I have to spread them even further apart to get that down there. They still don't line up. Wow! All right, let's grab something a little gentle. Wow, look how far those are. Those are that far apart to be able to get, and they're all the way up, like they're on there. Why am I trying to force my head down there when the easy way is to just put the screw in, see if screw hits a hole. Screw hits the hole. Okay, so that one lines up. Grab my other screw. That one line up. Yep, we're in the holes. Okay, and just barely makes it. And I'll bet as I tighten this in, that's going to spread those out a little bit more. So let's screw that in. And you're going to grab a pair of screws. You're going to need a pair of M3 by 14. He calls for socket head screws, but I didn't have any in my hardware kit. But that's no big deal. So I'm going to show you how to measure them. These are pan head screws, so we're not dealing with the sexy black oxide ones. And for these, you don't just measure the whole screw like that. You'll end up, like we got 16 millimeters. You want to measure from under the head to the end, and we got about 14 millimeter, okay? And these are M3 screws. So we're going to bolt this on here. Let's see if I can start it by hand, if I'm lucky. Not really. Let's fight a screwdriver. This would be this step in the manual. If I were rewriting the manual, I would put this step before you put this motor in place, because it's kind of a pain in the butt to get in here. Or if I had like a foot long #1 Phillips, a #2 will just about fit. Doesn't like it. It's not happy about it. Yeah, there's no easy way to get in there with this in the way. Did I mention that Chris Annan hates you? He does this just to punish us. So I'm going to take this off, which is a pain in the butt because that's all, like I did the whole belt thing. I got all that happening there. So I'm going to take the motor off a second just so that I can be sure I got this in there. And before I do that, oh, I fucked it. I fucked it. We got to do this all over again. All right, so I'm going to take a minute. I'm going to take this off. I'm going to prep a new switch because this doesn't click anymore. So we get to autopsy a switch and see how I screwed that up. That'll be cool. It's probably going to be one of these three. So I'm just going to take this motor right out. The entire J1 motor and mount before we do this. But I am submitting my official recommendation for a design change on the A3 version 2 to make the J1 turret 1.5 inches taller, measured from the bottom. Just add 1.5 inches on the bottom. Everything else will be fine. We'll have to adjust a few other parts. It's not a big deal, but this is This is one of those things that's bad and easy to fix. And you'll come across this a lot on things that you build. You will learn the lesson. Like, one of the first things you'll learn as you get into CAD is it's really easy to draw a part you can't build. So I'm going to take this all off. Now, other people making video, oh, it clicks again. What the fuck? Oh, if I push them apart, it don't click. All right, so we're gonna have to bend these in a better, more gentle way. And I have some ideas on that. But we're gonna open this up. Other people would make a video like this and just edit all that out and not show you, oh shit, I broke the part. No, I'm not gonna do that because this is real. And this exact kind of thing will happen to you. You will break the part and fuck it up. And I don't want you to feel stupid because you're not. You will make mistakes. I make mistakes. And I want you to learn that this is iterative. You're gonna do things over, you're gonna take 3 steps forward and 2 steps back, and that's just how the world of engineering works. And it's important to show people that. If you want one of those shows where shit just works right the first time, you gotta like get on PBS or something because I don't do that thing. So what I'm gonna do is try carving my way into this a little bit. Now it's very possible that in doing this, I'm going to have parts of this go, shoot. I'm gonna put on safety glasses because I know there's a spring in there. And not that I've ever gone at something with a pair of cutters and shot pieces into my face or anything. You think I was born looking like this? No, this is years in a shop of shooting parts at your face. But I'm just gonna, there we go. Okay, so let's slide that out of the way. Let's look in here. I'm gonna pop the top off. This is our first look inside. And there's what we see. So that's pretty cool. Now what happens when you bend these apart, when you tweak that, is you bend this piece down so it's not moving right. Let's grab another switch. Hey, I happen to have this one right. No, that one's riveted shut. Okay, let's grab another switch. Don't worry, I got lots of them. Let's grab another switch. Now this is the one that we mangled to hell. Let's cut open another one and get a look inside and see how that looks different. Come on, little buddy. There you go. Oh, shit. Okay. So here's first look inside one that isn't all mangled to shit. And do you see the difference? By doing the modification of forcing these so far apart, this is acting as a fulcrum, and while this is bending here, with the fulcrum here and putting that force in here, this collapses down and the switch doesn't, like, see how these are parallel? And that whole actuator arm, there's a buckling spring here, and this is the actual contact moving. And over here, it's all mushy and jank, and this isn't, because this contact arm floats. Over here, it's all fucked off out of position as not doing it right. So when we bend these, it's important to not put that force on here. We got to keep the force out here. So how the hell do we do that? Not entirely sure, but we're going to figure it out. Or I'll just try bending another one and see if we can do it without fucking it up. But what I'm going to do is, instead of bending way out here and levering down, I'm going to see what I want is a pair of needle nose that'll hold that the way I want it. I've got about 1 millimeter. I might have a tool for this. I'll be right back. I got an idea. I have these. Now these are, here, I'll show you the part numbers. And they're super thin. Let me compare these with a pair of my cheap cobalt needle nose. See how much thinner they are? And they're square. These, they go down to the same thickness at the end, but these are way beefier, way fast. These are super wheedly little light duty things. And I got two sets, one smooth, one serrated. So I'm gonna grab here, like that, with the serrated jaws. And I'm gonna grab with the big jaws over here on the other one. And I'm gonna tweak that like that, as hard as I dare. Because now I'm not putting any force on the inside of the switch. Right? And I'm gonna bend those way the hell over like that. And I'm gonna go on this one. I'm gonna hold that still. And let's try it with the other ones. I'm gonna bend that from up there way the hell over like that. Okay, so now I'm off at like a 45 on each. And now we can put our common white on. Wait, Jet, am I going the right way? Yep, okay. Put our common white on. And our normally closed black. Now this is only going to go on that far, but we've got plenty of engagement. This is low current, low voltage. I'm not going to sweat it. I've got enough engagement that those all work, and my switch still feels good. Now I've dropped down, you know, probably almost a 1/4 inch on each. So we're going to have to spread these out even further before we're done. But let's see how it fits. We got to get down a little bit, but not by much. I'm really close on that. Yep, we got to get down a little bit. So let's pop these off. Oh. Yeah, there's a good solid mechanical connection there. That's a thing to keep in mind. There's a difference between a mechanical connection, the thing is on there good, and an electrical connection. It's absolutely possible to have a really good mechanical connection and have a terrible electrical connection, or vice versa. All right, so we're gonna grab our special little pliers, and I'm gonna bend these out even further. And I'm going to give this a kick over too a little bit. So that's what my switch looks like now for reference. Okay? So our white goes on our common. Our red goes on our normally open, number 3. And our black goes on number 2, normally closed. So that's what my switch looks like now. That's how much I had to spread that out because Chris Annan hates you. Clearly. Oh, and it's right in. It's beautiful. Line's right up. Okay. So that's where you want to be. See, we solved an engineering problem. We got to explore microswitches. We got to learn stuff. And then I'm just going to screw this right on here like that. So, things we learned. 1, that tower should be 1.5 inches higher. I'm saying 2 inches. Just bring the length, man. 2 inches. Get that fucker up there. So I'm saying the tower should be 2 inches higher, and that would make this just super easy. If it was just an inch higher, it'd make a hell of a difference. But at 2 inches, we wouldn't need the right angle fittings. We could just have regular straight crimp connects and go straight down, and that would be awesome. That's where you want to be. So I'm saying 2 inches on the J1 turret tower. So now we got these all over the damn place. We got wires laying everywhere. So what we got to do is we got to cut off a piece of this. We're going to need our sexy Chinese finger trap stuff. What do they call this? PET braided sleeve. So this is just cable sleeve. So we're going to cut a piece of this braided cable sleeve to 9.5 inches. That's 19 centimeters. So I'm going to lay it out on my thing. I'm just cutting an even 10 inches because, no, I'm doing 9.5. Book says 9.5, I'm doing 9.5. All right, so we'll cut this off. I'll cut my wires a little long because those are easy to trim off. But this stuff you gotta melt the end to get it happy. So I'm just gonna leave that there because it's hard to trim this off once the wires are in it. So I'm gonna run my hand down this because it's got a flat axis from sitting on the roll. I'm just going to kind of fatten it out a bit. And you just squeeze the wide axis and make it rounder and fat. Oh! You got to melt the ends on both ends. Oh, it's because I cut a piece off last time. That's a lesson learned. All right. So we'll stuff this in here. Now, silicone wire is grabby in situations like this. But this stuff you can very easily compress like this. And it's easy to compress, it's just hard to hold. But you can shove wires down it a lot easier when it's compressed like that. So you're actually trying to push this from the bottom, but it's tricky because while it does instantly get fatter, it wants to spring off in different directions and gets a lot harder to hold. So that is left as an exercise to the viewer. That's the thing you'll read in technical manuals as you explore more stuff. You'll come across things of this is left as an exercise to the reader. That means we have no fucking idea. We just swore at it for half an hour and finally figured it out. And you're on your own here. Yeah, there's no easy way to do that, really. Yeah, that's a complete pain in the ass. There's got to be an easier way to do this. What am I doing wrong? What if I stick this in there, fatten it out? See, that pushes the wire back out, but it lets me fatten that up a lot. See, it's really easy once you can get the tail of the wire out. And what I'm trying to think of an easier way to do this. There is an easier way to do this. There's some old trick that the case mod guys have got all worked out. That I'm just not privy to. There's some dark secret that they know. Oh, I'm almost to the end. If I'm almost to the end, can I, oh, hey, you can, that actually works. You can scrunch it and like caterpillar your way up. And once you're at this end, it's really easy to push it up. Like that's super easy to do. I'm gonna take that all the way up there and then work that down. So we're cool. I'm gonna grab a big fat zip tie. Now I have smaller zip ties. I have these little zip ties, but I'm gonna put a big wide one on here because I'm using this like a cable clamp kind of. And I wanna spread the force out. So a wider zip tie is better. Not a longer one because you only need a little bit of it. I'm going to put that down just a little bit and then set that really tight and then cut it off flush because we always flush cut our zip ties. There's a reason for that. Whenever you're working with zip ties, you want to get a good pair of flush cut nippers, and these are cheap as chips. There's a million different ones of these out there, but Klein and Knipex both make very good versions of this. Own a pair of these, and whenever you work with zip ties, come right up to the body like that and cut them flush, because if you don't, if you just cut them with regular cutters that aren't flat flush cut cutters, you'll leave a little sharp pokey bit on there and they'll slice the hell out of your arms and hands when you're working and stuff. Because I have soft, delicate, dainty, the hands of a gentle woman. So when I'm in this stuff, I get cut up pretty bad. And no matter how tough you are, like big, rugged, Joey hands, this through here, still really soft meat. And it turns out people are just made of meat. And if you don't flush cut your zip ties, you're gonna, like, you'll get into a box and working on stuff and you'll chew the hell out of your arms. So just cheap, simple flush cutters, use them. I just spun that around and it smacked the thing because there's no motor on there now to limit it. But we can hear that that works great. So our J1 limit switch is installed, and now it's just a simple matter of putting the motor back in there. So let's reinstall the motor. Pulley's good. Wire off the back. I'm going to gently bolt the motor down and then have the fight with the belt. Oh, people who were closely watching the episode where we mounted this motor will note that I installed the motor, the tension screws back here, but I never tensioned them because I'm going to do that when we get this all sorted out and things start moving and everything. But that's another thing that should be done, I recommend. That step should happen before putting the whole back on, because you're going to have to take the whole shroud off to do it, because you can't get a tool in there. Or maybe in version 2 of the robot, well, A32, we could move the housing on the back, the big black housing. We could add an inch of space here to be able to get a tool in there. That'd be a cool thing. Because yes, you can do it, it's just a pain in the butt. And robotics is hard enough just on its own. This is complicated stuff we're doing here. So we don't have to make it harder than it needs to be. It's plenty hard all on its own. So let's see what we can do to make it easier on people, especially people building these robots, because it's going to be young people just starting out. So I'm just going to squeeze that and tighten that down. Okay, and there you have it. It's on, And our motor and everything works the way it's supposed to. And now, boop, a good positive limit stop. That's really cool. Made a whole thing there today, and we've got our wire on, and that's all sorted out, and everything's just good. So I like it. And that is episode 7, the J1 limit switch. We got to explore limit switches, and we got to learn about inside them and see the difference of how they can fail. We got to study a failure mode. We got to see how this can get that all bent and kitty-wumpus. We got to learn a new word today, kitty-wumpus. So yeah, it's a good time. Thank you guys for hanging out and building a robot with me and learning some shop skills along the way as we go. I know this is a long video. It was a lot longer than I expected, but my goal with these videos is to go an inch wide but a mile deep. And if we had the opportunity to explore a failure mode on a switch, I'm in, because this is limit switches. And yes, you're learning how to build this robot, but I'm also trying to teach you everything I can for the other stuff that you're going to build. And while, yes, you're using a microswitch as a J1 limit switch on this robot, you're going to use microswitches for a lot of other things. They're everywhere. There's microswitches in my laser cutter and in my garage door opener. They're everywhere. And it's important to learn this stuff because these are skills you're going to carry with you for the rest of your life. And I'm here to teach. That's my job. So if you like this kind of thing, if you like exploring this, then let me know. I want to hear your opinions. I want to hear your thoughts. There's a whole comment thing down below for a reason. I really appreciate you watching this. This is serious nerd video. We're not making cat videos. 99% of the internet is never going to watch this video, and I'm fine with that, because the very tiny few people that have watched this video this long and gotten this deep into it, you've learned a bunch of cool stuff. You've gotten to explore things, and you're the smart people. You're the people that are going to make a difference in the world. Okay, it's easy to make cat videos and get a million hits on the internet. It's hard to make videos that educate, inform, and inspire, and that's what we're here to do. I want to help you make cool stuff and put it on the internet because I want to help you develop a curious mind and learn how to solve problems and use critical thinking, because you're going to become a person who goes out in the world and asks questions and demands evidence and solves problems. And that's how we make the world a better place. This stuff, studying microswitches, is my little way of this is how we're actually making the world a better place, because we're creating people that ask questions, demand evidence, and solve problems. So this is bigger than just robots. This isn't just we're making a cool robot. We're changing the world. And that's really awesome that we can do that. And that's why I make videos that are so damn long, because this matters. So thank you for watching the whole thing and hanging in there. You're awesome. And I hope you are actually building your own robot, whether it's a ARchi3 for Man in Robotics, or you're playing with an old ABB, or you're just throwing parts together with an Arduino. I don't care. Make something cool and put it on the internet. Thank you guys for hanging out. I really appreciate it. You have fun. I'm Chris Boden, and I'll see you next time. Project Archi, Episode 7, Sync.